Question 9. Consider the graphs of g of x, which is equal to x cubed minus 3x squared, and h of x is equal to negative 2 over 3x minus 4 over 3. And we are asked in part A to determine whether the graph of h intersects the graph of g at its point of inflection. So what we could do is we could work out the actual point of inflection of g of x by taking the double derivative and setting it equal to 0. So we'll first work out the first derivative, g prime of x, which is equal to 3x squared minus 6x. So the double derivative will be g double prime of x is equal to 6x minus 6. And if I set g double prime x to be equal to 0, I'll be able to get the x value at the point of inflection. So 6x is equal to 6, which means that x is equal to 1. To get the corresponding y value, we can now substitute x is equal to 1 back in the original formula for g of x. So g of 1 will be equal to 1 cubed minus 3 into 1 squared, and that's going to give me 1 minus 3, that's going to be negative 2. So the point of inflection of g of x will be the point 1 and negative 2. Now all we have to do is check if this point lies on the graph of h of x. So in order to do that, we can just find h of 1 and see if it gives us the corresponding y value of negative 2. So h of 1 is equal to negative 2 over 3 times 1 minus 4 over 3. That's going to give me negative 2/3 minus 4 over 3. That'll give you negative 6 over 3, which is indeed negative 2. So we do replicate the corresponding y value at the point of inflection of g. So therefore the answer will be yes, the graphs will intersect at the point of inflection of g of x. Therefore, g of x will intersect h of x at the point